So, we're trying to find volumes of revolution using the shell method. What do they give us? They give us that y is x to the fourth, and they want us to bound it by y is equal to 0, and they want us to bound it by x is equal to 1, and the axis of spinach is x over 2. So what do? First, we got to graph that guy. And there's a good graph by our app Good Grapher. Yeah, sure. What are we looking for? We're looking for this region in here. Yeah, all this blue stuff. You my boy, Blue? Yeah. So we're looking for that blue stuff. And what? This is our axis of spinach. Great. What's our region of integration? That's this stuff in here. Whoa, whoa. Everything's going crazy. All right. So we're integrating with respect to x because we're doing the shell method, and the shell method goes parallel to the axis of spinach. We've drawn a lot more here than we needed to. That was gonna come later. But anyways, let's look at this. Our distance away from the axis of spinach is this stuff right here. That circle didn't work out. Anyway, yeah, this distance here is our distance away from the axis of spinach, and we find that if we take the total distance 2 and we subtract off this x, what are we going to get? Our distance away from the axis of spinach is 2 minus x. What's next? Well, let's go back here and see. Bam! Now we can set up our integral. Yeah. So our integral is going from 0 to 1. All right, because that was our bounds on our x. And then we have our 2 pi, and then we have our altered distance away from the axis of spinach, our function, and dx. After that, it's routine, like a ground ball. I pull that 2 pi out, and I multiply that x to the fourth in. Then we go ahead and we integrate that. Sure, that's. Are we in a club? Add 1, divide by it. That's 2/5 x to the 5th minus x to the 6th divided by 6. And then we're going to use the fundamental theorem of calculus, and we're going to upper minus lower. And that's what's happening here. All right, minus that monkey. Okay, simplify it. And it turns out to be 7 pi's over 15. Box and flower.